Hi there. So in this video, we're going to be talking about equations and determining if values make equations true. And then we're also going to look at how you can write an equation from a model, given a model. Okay, so the first thing we want to do is just sort of define what an equation is. An equation is actually a math sentence. Yes, we have sentences in math. It's a sentence that states that two quantities are equal. And so that's important. You can't have an equation without an equal sign. So every equation is going to have that equal sign. All right? Another thing you're going to see in equations most of the time is a symbol that is being used to represent a number. This is called a variable because it can vary, okay, based on the equation. And usually a variable is a letter like X or A or W. But it can be just a regular symbol too. And then you're also going to see inside equations numbers, and there are kind of two kinds of numbers you might see. Some numbers are going to be next to the variable, and when that happens, it's called a coefficient. And some numbers might just be added. You might see something like 2x plus 4, and when that happens, that number is just a constant. Okay, so it's got a special name when it's in front of the variable. It's called a coefficient. And all variables have coefficients, we just don't always see them. So if there's no number in front of the variable, then the coefficient is automatically a 1. So here's an example of an equation, x minus 7 equals 9. There's no number in front of that x, but it's understood to be just a 1. And then just remember that anytime you have a number next to a variable, that's telling you multiplication, right? Okay, and then when you find a value that you can substitute, that you can replace x with, okay, that makes the equation true, what you've found is called a solution. So the solution is the value of the variable, the letter, okay, that makes an equation true. An equation's true when both sides are equal. Okay, so remember you've got that equal sign in the middle. And so on either side of the equal sign, you want that to be equal to the same number. All right? So here's an example down here. The 3n plus 5 equals 17. That's an equation. Okay, we see the equal sign there. That's an equation. All right, so let's label it as an equation. Okay, our variable, if we look at the number, we've got several numbers, but we only have one letter, and that letter is called the variable. And in this case, there is a number that we see in front of the variable. And remember, we're calling that the coefficient. All right, so the equation has the equal sign, right? The variable here, in this case, is n, and the coefficient is what's in front of the n is the 3. All right? And we have other things in the equation. Okay, we have this 5 and we have the 17. Okay, there's no variable next to these. So these are both just called constants. Okay, and then the last thing we can see here is this addition sign. Okay, that's just an operation. All right, we're not going to label it because we're kind of at, oh, I guess I can draw it in there. That's an operation. And these combinations of the equal, the operation, the letters, and the numbers, okay, all make up equations. All right, so one thing we want to do is we're going to be looking for solutions that make the equation true, for the numbers that we can put into the variable that make this equation true. An equation is true when both sides are the same. So if we look in this equation, same equation, but they've replaced n, the variable, okay, with a number, right? So in the first time, they replaced it with a 2, right? And remember, a letter next to a number means multiply, so that's why this is in parentheses. We're going to multiply 3 times 2, that's 6, and then add 5. So is 6 plus 5 equal to 17? Is that true? No, that is not true, all right? So 2 is not a solution, right? Then they replace, this time n, they replace with 3. So 3 times 3 is 9. If I add 5, is that going to equal 17? No, 9 plus 5 is 14. That is not 17. So 3 is also not a solution, okay? And then they tried replacing n with 4. So now I have 3 times 4 equals 12. Plus 5, is that equal to 17? Yes, 12 plus 5 is 17. That means that 17 would equal 17. Both sides would be equal to the same thing. That means the equation is true, so 4 is a solution. All right, 4 is the solution because it made both sides the same. All right, The last thing we're going to kind of define, and then we're just going to practice a little bit, something called equivalent equations. Okay, and equivalent doesn't mean they're exactly the same, but it does mean they have the same solution. So we just solved this equation here. We found the solution was when n was equal to 4. All right, so if we look at these other equations down here, these are also equations. They have that equal sign that we have to have. Is n also equal to 4? Yeah, if we replace n with 4, are both sides the same? Yes, then this is an equivalent equation to 3n plus 5 equals 17. Okay, same thing here. If we replace n with 4, that would be 3 times 4 equals 12. Okay, is that going to be equal to each other? Yes, that's going to be equal. But this is also an equivalent equation. Right, and then if you look at the last one, if we replace n with 4, is 4 plus 1 going to equal 6? No. Okay, then this is not an equivalent equation. 4 plus 1 is 5, so both sides would not be the same thing. All right, so let's look at some of the types of problems you're going to see on the homework. It says determine if 3, 4, or 5 is the solution to this equation, c plus 5 equals 9. And basically, when you're trying to determine if something is the solution, you're just going to replace the variable, the letter, with a value, all right? And in these problems, they're going to give you what to replace the variable with. So we've got 3 numbers we want to try, all right? We're going to check after we replace the variable to see if both sides are equal to the same number. Okay, if they are equal, if each side is the same, okay, then that means the value is a solution. That's what we're looking for, solutions, right? And we have to try each value to make sure we found the solution. All right, so let's just see how it works. So I'm going to take 3 first and replace the variable with 3. I'm changing the c to a 3. Is 3 plus 5 equal to 9? Nope, then 3 is not a solution. Okay, if I replace c with 4, then I would have 4 plus 5 equals 9. Is 4 plus 5 equal to 9? Yes, it is. So that tells me 4 is a solution. So I'm going to circle it. And last one, same equation. I'm going to replace c with 5 this time. Is 5 plus 5 equal to 9? Now, if 5 plus 5 equals 10, that's not a solution, so 5 is not a solution. The only solution to this equation is when x is equal, or c is equal to 4. Okay, so we could say c equals 4 is the solution. All right, and I got the c because that's the variable they were using in this equation. It can be any letter, so it's just whatever they give you, or if you get to decide, you can choose your favorite letter. All right, on number 2, determine if 3, 4, or 5 is the solution to the equation 5 plus 2x equals 11. All right, so again, I'm going to replace the x, the variable, with 3, and then 4, and then 5. So remember, the coefficient is 2, and that coefficient is being multiplied times the variable. A number next to a variable means multiplication. I'm going to write this with parentheses to remind myself to multiply. Right? And then because I have both adding and multiplying here, I always start with multiplying, PEMDAS, remember that? So 2 times 3 is 6. If I add 6 plus 5, I get what? 11. All right, so that looks like 3 is the solution, but I'm going to try each value. So I'm going to keep going. If I do 5 plus 2 times 4, is that going to equal 11? Well, again, start with your multiplication. 2 times 4 is 8. Is 5 plus 8 equal to 11? Nope, 5 plus 8 is 13. This is not a solution. 4 is not a solution. Okay, and then the last one, 5 plus 2, and now x is 5. So if I multiply first, 5 plus 10, is that going to equal 11? Nope. All right, so 5 is also not a solution. So the only solution, only thing that works, is when x is equal to 3. That's my solution. All right, and number 3, it says determine if 2.4, 2.7, or 3.6 is the solution to the equation d over 3 minus 1.4 equals negative 0.5. Oh, there's an extra decimal. It's not supposed to be there. Okay, I'll fix it on yours. All right, so we're going to replace d with each of these numbers. Remember, a number over another number in this fraction notation right here also means division. So I'm going to divide before I subtract because division comes before subtraction. And then I'm just going to look, make sure whatever answer I get is not just 0.5, but negative 0.5. All right, so 2.4 divided by 3 minus 1.4. All right, and I want to know if that's equal to negative 0.5. All right, well, 2.4 divided by 3, it's really just like dividing 24 by 3, but there's a decimal. Okay, so the decimal comes up, so that's 0.8. So now I have 0.8 minus 1.4. Okay, because I'm subtracting and I'm looking at a negative answer here, I'm going to go ahead and change my subtraction to addition. So I'm going to keep the 0.8, change to add, and then change to a negative, change to the opposite. So copy, change, opposite, or keep, change, however you want to think of it. So 0.8 plus negative 1.4, is that equal to negative 0.5? Well, when the signs are different, remember with integers, same thing with decimals, I subtract to find my answer. So 1.4 minus 0.8 is actually 0.6 because the 1.4 is larger, okay? And this would be a negative 0.6 on this side, right? Not a negative 0.5, okay? So that tells me that 2.4 is not my solution, right? Then I try the 2.7. I have 2.7, that's replacing D, over 3 minus 1.4. Is that equal to negative 0.5? All right, so I'm going to start by dividing 2.7 divided by 3. Okay, it's just the same thing as 27 divided by 3, but I'm going to use a decimal, 0.9. So that becomes 0.9 or 0.9 minus 1.4. Okay, I'm going to go ahead and change that to an addition equation. So 0.9, keep that. Change to add, change to the opposite, negative 1.4. And then if I actually subtract these, 1.4 minus 0.9, this time I am going to get 0.5. Is it negative? Yes. Because there's more negatives than positives, so this is negative 0.5 or negative 0.5, okay, which is what I want it to be, right? I want these two sides to be the same. So since this works, that tells me that 2.7 is a solution. All right, and then the last one, if I try it, 3.6 over 3, it's replacing D, minus 1.4 equals negative 0.5. I want to know, actually, if it's equal to negative 0.5. So if I divide 3 into 3.6, okay, 3 into 36 is 12. I just have to bring up my decimal. This is 1.2 minus 1.4. I'm going to rewrite that, keeping the 1.2, changing to add, changing to the opposite. And then is 1.2 plus negative 1.4. So if I go ahead and subtract those, then that's a 1. Then I get 0.2. Okay, and then this is actually a negative 0.2 because there was more of the negative than the positive. Okay, and again, that's not equal to negative 0.5. So this is not a solution. All right, so the only solution, the only one that made both sides the same was when D was equal to 2.7. Okay, as we continue in this chapter, you're going to be solving for this solution, but you also need to be able to test solutions, which is what we're doing right here. Okay, the last thing we're going to look at in this video is how you use a model to write an equation. All right, so you're going to be looking usually of models of algebra tiles, and hopefully we'll get to look at some of this in class as well. But these 3 long rectangles are considered the x, the variable, the part you don't know. All right, and so you would just count them. All right, 1, 2, 3. There are 3 x's, so we would write that as 3x. Okay, the equal sign you can see is already there. That stays in your equation. And then what is this side? Well, we can count what's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ones, which is just 12. So this model represents 3x equal to 12. And then in this one, we're not testing solutions, but we can go back later and learn how to solve for the solution. Okay. Sometimes it's not a tile. Sometimes they use different symbols or in this one, they're using a cup. Okay, we don't know what's inside the cup, so that's our variable. That's our x. So I have an x on this side, right? And an equation, this is kind of showing you that an equation is like a balance scale. Okay, you have one side over here and one side over here, and the balance scale has to stay balanced. All right, so x, and then I have 3 ones right here. So the way I would write that is x plus 3. Okay, because I have this, plus I have 3 more, is equal to what's on this side. Well, just 1, 2, 3, 4, 5. 5 ones are just 5. Okay? All right, we continue on to number 3. You can see this side right here, I have 2 x's. All right, so that side is 2x, and then I have an equal sign. And then this is kind of hard to read, but those are all negative ones. So I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8. So there are actually 8 negative 1s are just negative 8 on this side. Okay, this side was just x's because there was nothing else over here. Here's another way to show a model and equation. This is kind of like the balance scale idea. And this time they're using a triangle to represent what we don't know. So this is our x. Okay, then on the side, if I drew a line down here, then also with x, I have 1, 2, 3, 4 negatives. All right, so I could say x plus negative 4. And then on this side, I have 1, 2, 3, 4, 5, 6, 7 negatives. 7 negatives. Okay, so I can write x plus negative 4 equals negative 7, or I could rewrite this. Another way to write this is to say x minus 4 equals negative 7. Okay, because subtracting 4 is the same thing as adding a negative 4. All right, look at the next one. You have how many x's on this side? 1, 2, 3, 4, 5, 6 x's. But that's not all. We also still have some 1s. 1, 2, 3, 4, 5. So we have 5 1s. So to show both of these on this side, I have to say 6x plus 5 1s, or 5, equals. And on this side, what do I have? Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I count those right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I thought it was 15. 15. Okay, and that's all that's on this side, so it's equal to 15. All right, and this last example, it's really light, but here you have the two rectangles again representing x. So there are 2 of them, so that would be a 2x. Okay, these look like 2 1s. 1 and 1 is plus 1, plus, there's 2 of them, so plus 2 on this side, then the equal sign. And on this side, we have 1, 2, 3, 4, 5, 6, 6 1s over here, or just 6. Okay? Because this has been copied in black and white, I'm not going to worry about positive and negatives, but when you're actually using algebra tiles, the color of the square often tells you if it's negative or positive too. So someone might read this and think, oh, these are all negative because they're, maybe before it was copied, it was red, and that's possible, but if they're green, then they're positive. Since we can't see it, we're just going to assume that they're positive. All right. Okay, so that is turning a model into an equation, and then later in this chapter, we're going to learn how to solve these equations. All right, see you soon.